Hi guys, welcome to this video on length and perimeter. Really good to see you. Thank you very much for dropping by. My name's Darren, Maffs Guru, and I'm here to try and help you. Never going to be rich, never going to be famous, but if you click like on the video and subscribe to my YouTube channel, it just lets me know that you're watching. Thanks very much for doing it, and tell your mates and your teachers. In fact, tell everyone, tell the world, tell TikTok. What are we doing with today? Length and perimeter. All right, so basically we're going to look at understanding that perimeter is basically a length. It's one-dimensional, yes, and it has units and all those exciting things. Convert different units of lengths, probably leave that towards the end. Be able to find the perimeter of a shape and then find the unknown side length when given a perimeter. All right, so perimeter. Yes, where I used to live in the United Kingdom, we used to have Royal Air Force bases, yes, and Royal Air Force bases would obviously have to be very secure. Likewise, prisons. Did you know there's a prison in Melbourne CBD? Ugh, scary, but not so scary, all right? So the point of it is, around the Air Force base is this massive fence, and around the prison, massive brick walls go very, very high with bars on them. If I was to start in a corner, and walk all the way around the edge, all the way back, then I've just walked around the perimeter. That's it. Perimeter is the outside. Now, obviously, maths being maths is going to try and trick us because later on, when we deal with circles, we don't call it the perimeter. If I start at the circle and move all the way around, then for some stupid reason, thanks Barry, it's called the circumference. Okay, it's called the circumference. Yes, I know. But every other shape, triangles, rectangles, squares, all the ones we deal with, it's called perimeter. And the point of it is nothing more than a distance. It is a distance you travel when you go from one corner and walk all the way around until you get back to where you start, all right? So it's a distance, it has a length, because distances are measured in lengths. So how do we find the perimeter of shapes? Well, first things first, we need to know the distances. So if I deal with something really simple to start with, and we have obviously a rectangle, yes, and I told you that there was 10 centimeters and that there was 20 centimeters. There's lots of hidden information in this question. So those little marks on each of the sides mean that they are the same size length, right? So very, very important. So we know that that length there and that length there are exactly the same. And in the same way, we would know that this length here and that length there are exactly the same. Now, sometimes I'll say to students, we'll write on the 20 and write on the 10, just so that we know. And then quite literally run your finger around and then add up each of the values. So the working out you should say P equals, for perimeter is equal, and I would do 20 plus 10 plus 20 plus 10. Ka-ching. So 20 plus 10 is 30. 20 plus 10 is 30, and add those together, it gives me 60. Now, 60 what? Well, again, we've got units given to us. So the units are critically important, and I would write centimeters. And in a test, you would probably get 1 mark for the answer, 1 mark for your working out, and 1 mark for your units, right? That's 3 marks. If you just put 60 down, you've actually only got 1 out of the 3 marks. So you're shooting yourself in the foot if you don't do the working out. All right, so that's a perimeter. What else? E.g., let's do another shape. Let's do a triangle. Does it change with a triangle? Not at all. If they told me that that was 1 meter, 3 meters, and 5 meters, then do I have all of my distances around? I should cocoa. I do indeed. So what I'm going to do is I write P equals, and I'm going to start here, and I'm going to go 1 plus 3 plus 5. So 1 plus 3 plus 5 gives me 4 and 9, and don't forget my units of meters. And believe it, I can't see anything more complicated than that for basic shapes, right? We'll come back to the circle some other time. Now, where this gets funky, and I love these type of questions, is shapes like this. All right, so when I have a shape like this, I may tell you that that's 10 meters, and I may tell you that that is 9 meters, and I may tell you that that's 3 meters, and I may tell you that there is 4 meters. these questions, this question here particularly, is a bit of a trick. All right, now I'm going to show you how most people work this out, because they go, oh, okay, I know that total length there is 10. I know that that's 3. And I know that those two there must add to make 10. So that's going to be 7. And I put the meters, right? Because again, those vertical bits there, assuming these are right angles, assuming they're all right angles, then that makes sense. That 7 and the 3 make the 10. And then they'll go, okay, so I know that total length there is 9. This bit here is 4. That bit there must be 5 because they must add up because they're the same length together. And then they'll go, okay, so perimeter is equal to, right, so started and end, 10 plus 9 plus 3 plus 4 plus 7 plus 5. Whew. So do it in pairs. 10 plus 9 is 19. 3 plus 4 is 7. 7 plus 5 is 7, 8, 9, 10, 11, 12. Yes, I did use my fingers. 19 plus 7 is 26 plus 12, which gives me 38. And don't forget my units. And then everyone goes, whoo, a lot of working out, yo. And I go, yeah, a lot of working out. Because there was another way to think about this one. And these are very specific to these type of questions. So let me just try and work it out. Let me just try and draw it again very badly. So there's 10 meters. And there's 9 meters. And what did I say? 3 meters. And I gave you 4 meters there. Now, what I want you to imagine is that I've got super strength. And what I'm actually going to do is I'm going to push this line upwards. And if I push that line upwards to the top of the shape, it's going to suddenly end up there, isn't it? Yes? And now I'm going to do the same thing with super shape here, super strength there. And what I'm actually going to do is I'm now going to move that to here. And what do you notice? If I've moved them and I get rid of this altogether, then lo and behold, I've suddenly, and I don't need that 3 there anymore, I've suddenly got a rectangle. And I happen to know that that length there, oops, that length there is 10, and that length there is 10, that length there is 9, that length there is 9. And so I actually can now do my perimeter is 10 plus 9 plus 10 plus 9. 19 plus 19, which equals 38 meters, and there's my answer. Now, again, to go back to the example, you may also notice that this 10 plus 9 and this 10 plus 9 is repeated because we get 19 and 19. And in fact, if we go back to that previous first example, same thing happened, 20 plus 10, 20 plus 10. Now, with rectangles, yeah, we can actually do something pretty funky, because so long as I know this side length here and that side length there, so if we call them A and B, then what we know is we can add the A and B together and then effectively just double it. We can times it by 2. Yeah, because we know that this length here is A, that length there is A, that length there is B, that length there is B. Now again, I'm using letters here as part of algebra. You've done a little bit of that in year 7, but ideally for a rectangle, add those two together and then just double it for a rectangle. Now, because maths is nothing more than big fat tricks, they can sometimes do it the other way around. So if I gave you this shape here, and I told you that that was 5 centimeters, and I did an arrow there and an arrow there, a mark there and a mark there, and I told you the perimeter of that was equal to 19 centimeters, then what you're now going to try and do is do it backwards. How are you going to do it backwards? Well, there's lots of ways of doing this, but what I now know is that this distance and this distance and that distance added together give me 19. Okay, so they give me 19. But we already know that this distance here is 5. So we now know that the distance here and here added together must be 19 minus 5. So we know that if I was to do, I'm going to do this as a side calculation, 19 subtract 5 actually gives me 14. Now, how is that going to help me? Well, because these little marks tell me that the sides are the same length, that means that therefore that 14 is shared equally between those two sides there. So if I do 14 divided by 2, that will give me 7 centimeters. And so each of those sides there are given as 7 centimeters. Now that's one way of doing this. They may actually give it to you in terms of letters. Again, algebra is going to be everywhere, ladies and gentlemen, pretty soon. Later on in this chapter or this textbook, we do a load on algebra, and I love teaching algebra. So they may actually put letters there. They may put an X and an X. Now the reason they're using the same letter there is because you've got those two little dashes, which mean they're the same length. Again, assuming the perimeter is 19 centimeters, this is now how we would do our working out. So we would first off say perimeter equals, and we work it out as normal, x plus 5, and we would write that down. X plus 5. But hold on a moment, we know what the perimeter is. It tells us it's 19. So I can now write 19 under the perimeter. We know that if we've got an x plus an x, then we have two x's plus 5. Right, okay, well we want to get the x's on its own. So what I'm now going to do is I need to take away 5 from both sides, which gives me the 14 equals 2x. All right, so taking away 5 from both sides to keep these things balanced. 2 x's are 14. So if I now divide both sides by 2, we get that x is equal to 7. And again, that's just another way of working it out. Most people would probably do it the first way. Last part of this video, ladies and gentlemen, how long have I been going? 11 minutes again, is converting units. Really, really important. If you're in United Kingdom, if you're in Australia, you are allowed to use the summary book. So converting units. We can measure length in lots and lots of different ways. So probably the smallest one we're going to use, and we're using metric here, is millimeters, centimeters, meters, and kilometers. Right, now we can convert between them by knowing how many millimeters are in a centimeter, centimeter in a meter, meter is in a kilometer. So if I'm going from centimeters into millimeters, we know there are 10. So I simply times by 10. Hold on a moment, we're back to that bouncing decimal stuff. Yes, we are. If you haven't watched the video, it's really, really good. We know there are 100 centimeters in a meter. And we know there are 1,000 kilometers. Sorry, there are 1,000 meters in a kilometer. So if I'm going that way, from kilometers to meters, meters to centimeters, centimeters to millimeters, I times. Now, obviously, because maths is funky, if we go the other way, then we do the inverse operation. So in this situation, I'm going to divide by 10, divide by 100, and divide by 1,000. If I were you, download these notes, copy this into your summary book with some examples, ka-ching, or cut it out and stick it in, whatever. Let's have a go at some questions. So, e.g., so I want to convert 5.2 centimeters into millimeters. Right, difficult? Not so much, because I'm going from centimeters to millimeters. I'm going to go from that to that. There's the direction of my arrow, so it tells me I just need to times by 10. So I'm going to do 5.2 times 10. I'm going to bounce my decimal one place, because when I times by 10, I move my decimal point 1 to the right. And so that gives me 5.2 with the decimal point on the end, but we don't need to leave the decimal point hanging. And so my answer will be 52. And don't forget your units. They gave you that they wanted it in millimeters in the question. So you must make sure you do millimeters here. And the last example is going to be 85,000 centimeters into kilometers. Right, so we're going from centimeters into kilometers. So I've got to go to meters first, and then to kilometers. So I'm going to divide by 100 and then divide by 1,000. All right, so divide by 100. I'm just going to write that down to remind myself. Divide by 100 and then divide by 1,000. So 85,000, the decimal points at the end. I'm dividing by 100, which means I'm going to move my decimal point 2 places that way. 1, 2. So that's going to give me 850.00, but we don't need to write all those point zeros on the end, so we just get 850. So now 850, okay, I'm going to get 850, and I'm going to divide that by 1,000. So I'm going to, there's my decimal point, move it 3 places to the left. 1, 2, 3, there is my decimal point. And so in which case I get 0.850. Now again, as I said in the previous video, writing that is actually wrong. First things first, you can't just leave a decimal point floating at the start. It has to have a number in front of it, and that number is always 0 if it's just there on its end. And we know that trailing zeros do not need to be written as decimals. And ladies and gentlemen, there we go. That is how to convert from centimeters to kilometers. I'm done. Thank you very much for watching this video. Hopefully you found it useful. If you have, subscribe on YouTube, like the video, tell your mates, tell your teachers, and hopefully I'll see you again. Take care, guys. Bye-bye. Thanks very much for watching, guys. Yes, this is the end of another video. If you haven't already done so, can you click on my subscribe button? Yes, it doesn't mean anything other than the fact that I know that you are watching. Yes, it's greatly appreciated. Otherwise, I feel like I'm sitting here just talking to myself. And then, yes, there is MaffsGuru.com, of which you can see a still of now. And what is over there? Well, all the videos ordered by textbook, ordered by topic. You can search for the videos. You can download notes, time codes, exam questions, and so much more coming up. Yeah, it's absolutely free to join. So I'm done. Thank you very much. I hope to see you in another video. Give me a shout out to your mates if you can. I just want to make sure that everyone finds maths interesting and easy. All right, take care, guys. See you again. Bye-bye. Stay safe.